This is video number 4 for sections 9.5 and 9.6, modeling with square root functions. As it says here at the beginning, we don't have time to do a full-blown treatment of this. I'm just throwing it in here to show you that the same kind of modeling that we emphasized earlier in the course can be used with any kind of function, right? We hit heavily linear, exponential, and quadratic functions, but any kind of function you ever learn about, this modeling process can be used. Let's take a look at the scenario here. We've got one of those typical let statements. P stands for the population of a town, measured in thousands. T stands for the number of years since 2010. And then we've got a couple of data points for this town in 2010. There were 3,000 people living there. In 2014, 11,000 people living there. The first thing we're being asked to do is adjust the data to fit the variable definitions. Well, let's see. T is number of years since 2010, so the year 2010 itself would get a 0. And that year there were 3,000 people. We're measuring in thousands though, so I just need to write 3. So 0, comma 3. And the second data point, let's see, 2014 would be 4 years after 2010, and it looks like the population was 11,000, so I fill in 11. Now, the idea here, if you go on to part B, is that somebody had a whole bunch of data points, more than just these two, and they drew a scattergram, and when they made all their dots, the dots had that kind of square root function shape. Remember we saw that in the last lesson? And so the person looking at the data decided, oh, I should use a square root function in order to model this real life problem. Here is sort of the y equals mx plus b for square root functions. It would be y equals a root x plus b. Don't worry about memorizing that. Again, we're not focusing on this heavily. Well, if we're going to use this model, it's not going to be very useful to us unless we can figure out what the a and the b are, right? Those two constants. And so this goes on to say, use the two data points that we just wrote down a minute ago, these two guys, in order to fill in the a and the b, in order to write down the correct equation. Well, it's the same strategy we've been using over and over and over, that temporary plug-in idea. These are XY points, right? Here's one, here's one. I'm just one at a time going to fill this information in for X and for Y in the hopes that that will help me identify the A and the B. For example, let's take that first data point and fill it in. All I did was replace the Y with a 3 and the X with a 0. Well, if you start cleaning this up a little bit, the square root of 0 is just 0. There's a times between those two guys. And a times 0 is also just 0, and so I believe what we've just figured out is that the b in this problem is a 3. Great, we're halfway done. In fact, if you're making connections to what we've done earlier in the course, I think we just figured out that the b in this model stands for the y-intercept. Right? We had 0, comma 3, the y-intercept. The b is the y-intercept. So I'm part of the way done. I now know that my model looks like this. Y equals a root x plus 3. I just don't know what the a is. Well, that's where that other data point comes into play. Let's go ahead and fill those numbers in for x and y. Remember, there's a times between this a and this square root. So the square root of 4 is 2. A times 2 would be 2a. And now I can do some simple algebra to figure out what a is. I believe we're just going to get a equals 4 after we finish off our algebra here. And now that I have my a and my b, I can go ahead and fill those pieces in back to my model. Now the directions did say to use the correct variables at the end. So our y variable in this problem is p. I have p equals, my a was 4, and then I have square root, let's see, my x variable in this problem was t, and finally plus 3. Here is the model that we're saying represents the population of this town. Well, again, just like all semester long, we would find our models and then we would use them to answer some questions. So let's try to do that. Letter C says, according to your model, how many people are going to live in this town in the year 2020? Well, I might have to refer back to my let statement. What was T again? T stands for number of years since 2010. 2020 would be 10 years later. So to answer this question, I just need to go to my model and replace the t value with 10. If I could work this out by hand, I would, but square root of 10 doesn't have a nice answer, so I'll have to reach for the calculator here. I got about 15.6. It does say round your answer to one decimal place, so we've done that. Let's make sure we're answering the question. How many people are going to live there? Well, we're certainly not saying 15.6 people. We're saying 15.6 thousand people. Remember, P was in thousands. All right, so there's our estimate for the population in 2020. Question D, I believe, is just a question in reverse. According to your model, in what year will 30,000 people live in the town? So I guess this will take place after 2020 when they're up to 15,000. How long is it going to be until there's 30,000 people living there? Well, again, it all just goes back to the model. I have P, I have T. This time they're giving me the P value. Don't write all those zeros, right? P is in thousands, so I just write 30 to mean 30,000. I fill that in, and then I would have to solve this equation for t. Well, that's exactly what we've been working on in this lesson, right? Solving equations that have radicals. Step one is get rid of the junk. And so I should go ahead and do that, right? Any of the stuff not inside the radical is junk that I should get rid of. And then I need to decide what to do with that coefficient. Remember, you can leave it if it's going to create a yucky fraction, which it would here. Why don't we do that? You could also divide by it if you didn't mind the fraction. If I was going to leave it, though, I would just jump ahead then to the square both sides step. When I square the left side, I'm just going to have to go to the calculator. When I square the right side, remember that 2 there distributes to both of these parts. This is a multiplication problem in there. So 4 squared would be 16. And when I square the square root, it simply makes it go away. I'm left now with a very simple equation to solve. Just divide both sides by 16. And since I am interested in translating this to an actual year, I should once again reach for the calculator here and divide. I get about 45.6. Let's see, it says in the directions round to the nearest year, so that would be about 46, I guess. And then I'm supposed to give my answer as an actual year. I refer back to my let statement. T is number of years since 2010, so this means 46 years after 2010. In other words, the year 2056. And that would be our final answer here. Again, we're not going to make a big deal of the modeling here, but you can see that the same procedures, the same types of steps we've taken all semester can be used with a variety of functions.